Okay, so let's move into the next section, known as trigonometric or polar form of a complex number. Now, a couple of things to remember that we've actually done and introduced in another lecture known as polar coordinates. We know the cosine of theta is x over r. So if you solve for x, you get r cosine theta, right? And sine of theta is y over r, so if you solve for y, you get r sine of theta. Remember these two things. Okay. So over here, the definition says the trig or polar form of a complex number, and remember what a complex number looks like, x plus yi. Remember, a complex number is the sum or difference of the real part and the imaginary part. And it's given by. Now, here's the interesting thing. This whole converting piggybacks off of something we did in the polar coordinates lecture when we were converting polar points to rectangular points and vice versa. So, let's go back to this definition. This complex number, the polar form of it, can be given by. Now, remember, polar has the point r and theta, not x and y, r and theta. So I need this rewritten. If I'm going to write it in polar form, I need x plus yi rewritten with an r and a theta in it. Well, I already know what x is, and it's got an r and a theta. I already know what y is, and it has an r and a theta. So interestingly enough, instead of writing x, we're going to write, good, r cosine of theta plus I times, and instead of writing y, we're going to write r sine of theta. Does that make sense? Notice they both have an r in common, so I'm going to factor it out. And when I factor it out, in the parentheses, I get cosine of theta plus I sine of theta times the r on the outside. This is the polar form of that complex number. Instead of having an x and a y, I've got r's and thetas. This is the polar form of it. Now, this is the expanded form, shall I say. An observation, these thetas are exactly the same angle. And they can be in degrees or they can be in radians, it doesn't matter. But the point is they're exactly the same angle. So we actually have a shorthand of writing the polar form of a complex number. And the shorthand looks like this. So watch. R, C for cosine, I for the imaginary, S for sine, and then theta. So RCIS theta is the shorthand for writing R times the quantity, cosine theta plus I sine theta. Cool? Okay, so we're actually going to do some converting of a complex number into a polar form, or the trig form of a complex number. And you're going to see some similarities from something we did in that other lecture on polar coordinates. So stay tuned. So let's look at these directions. They ask us to write these complex numbers in polar form. And in this particular case, they want theta in degrees, and it's greater than or equal to 0 degrees and less than 360 degrees. Now some of you may be asking, why is it not equal to 360 degrees? Well, isn't 360 degrees in the same location as 0 degrees? So you don't want both of them. It's either one or the other. So we're going to start at 0 and include the 0. We'll end at 360 degrees, but we're not going to include it because it's the same as 0 degrees. Okay, so here's something I need you to remember. From the lecture we did on polar coordinates, where we were taking our rectangular coordinates and changing them to polar coordinates, we had to change the xy point to the r theta point. Remember, okay, and I'm just going to write it down here. So remember, when we were changing rectangular coordinates xy into polar coordinates, remembering how we did this is actually going to help us with changing a complex number into a polar form. So here's the thing. Just like over here when we start changing rectangular coordinates to polar form, the first thing we had to do was find r. Well, actually, the first thing we had to do was identify what we have here. So if you remember the definition said, take your complex number, right? Well, my complex number in general is written as x plus yi. Well, then that means for problem number 1, x is equal to, good, 3, and y is equal to, excellent, -3. Are you with me? Because this is the generic form. X is the real part. Y is the coefficient of I, the imaginary part. So, this is what we know. And based on knowing x and y, just like over here we knew x and y, you can now find what? Yeah, that's right. You can find r. And how do we find r? Good old Pythagorean's theorem. X squared plus y squared equals r squared. By the way, does it say anything about decimals? Then you must leave it as an exact answer. Okay, so 9 plus 9, right? Yeah, 18 is r squared, which means r equals the square root of 18, which is, yep, some of you got it, 3 square root of 2. Remember, when you take the square root, this will be a positive and a negative answer. But since you're talking about r, which is a distance, it's always the positive answer, isn't it? Excellent. So we found the r. Now what do you guys need to find? Yeah, you need to find theta. So just like over here to find theta, notice we have x, y, and now we have r. So if you know x, y, and r, what can you find? That's right. You can find cosine, sine, tangent, all those other guys, can't you? Okay, so I'm going to find theta, and I'm just going to use the cosine of theta equaling x over r, which means the cosine of theta in this case is, that's right, 3 over r, which is 3 square root of 2. This can be simplified, can it not? And rationalized. Well, which angle has the cosine being square root of 2 over 2? I'll give you a moment. Yeah, the 45-degree angle. Now remember, this 45-degree angle is a reference angle. So we have a reference angle of 45 degrees. Why is it a reference angle? Because what else do you need to know in order to get the correct theta? You've got to know the quadrant. I have a positive x and a negative y. Which quadrant am I in? Yep, I am in quadrant 4, which means my theta is 315 degrees. Are you with me? Excellent. And you're like, well, that's all we had to do when we wrote the rectangular to polar. And that's right, that's all you had to do. However, you're not quite done here, because in this particular case, the polar form actually has not just r and theta, but it also has the trig functions in it. So this final answer is going to look like r, which is 3 square root of 2, and in parentheses, the cosine of theta, which is 315 degrees, plus I times the sine of theta degrees. If you want to write the shorthand, that would be the 3 square root of 2, c for cosine, I for the imaginary, S for sine, 315 degrees. This is the shorthand if you want to write the shorthand. Cool? Okay, so hang in there. I'm going to be right back and we're going to work on problem number 2 here. Okay, so let's look at this second problem. So again, they want us to write this complex number in polar form. So, just like we did the last problem, just like we did when we were converting rectangular points into polar points, right? We need to be able to identify our x's and y's so we can find our r's and our thetas. Agreed? Okay, so in this particular case, what do we know? Excellent, we know x and y, don't we? So, what's x in this case? Good, -2. What's y? 2 square root of 3. Excellent, because the I is separating the two parts of the y, aren't they? And so since that's our x and that's our y, what can we find? Good, so we can find r. Well, Pythagorean's theorem, x squared plus y squared equals r squared. Agreed? So we've got 4 plus. Okay, so you have to remember how to square radicals. So, okay, side work for some of you who are like, okay, show me again. Here's your side work. This is just multiplication, so I'm not distributing. So I'm just going to do 2 times 2, which is, and square root of 3 times square root of 3, which is, good. So that's going to be 12. Which means I get 16 as r squared, which means r, yes, is 2 answers, but r is always, excellent, positive, which means my answer is a positive 4. Cool? Okay, so you just found r. Now what? Yep, find the theta. Just like we did before. So I always tend to go to cosine of theta. Some people will find the sine of theta. Some people will find the tangent of theta. You know, it's totally up to you what you want to find. But this is what I go towards, is finding cosine. So I know cosine is x over r. So I know the cosine of theta is, good, -1/2. I don't know about you, but I think I need my triangle. And the triangle I'm going to draw is the 30, 60, 90, because 1 and 2 are on the 30, 60, 90 degrees triangle, correct? And so we have to remember how to draw this correctly. So, which angle that when I take the cosine of it, I first of all just get a half. Forget the negative, but you just get a half. Yeah, 60 degrees, because the cosine of 60 degrees is 1 over 2. So that tells me my reference angle is 60 degrees. Why reference angle? Well, which quadrant are we in? X is negative. Y is positive. Yep, this is a quadrant 2 deal, which means my theta in quadrant 2, knowing the reference angle is 60 degrees, the actual theta in quadrant 2 is 120 degrees. Awesome! Okay, I've got my r, I've got my theta, just like we were dealing with converting rectangular points to polar points, except that's not what I'm converting. I'm not converting points. I'm converting a complex number into a polar number. So, your polar form, r, which is 4, and in parentheses, cosine of 120 degrees plus I sine of 120 degrees, because those are the exact same angles. And if you want to write shorthand, 4 C I S cosine I sine of 120 degrees. Good? Does this make sense? It's kind of almost a refresher, isn't it? Except we have an extra step to take because in this case, we have to remember we're not converting points. We're converting complex numbers into polar form. Cool? So this is like your extra step to do. Hang in there. I'll be right back. Okay, so notice the directions. They say to write in rectangular form, which means we need to get rid of the r and the theta and get x and y back. Are you with me? Get rid of r and theta and get x and y back. So here's the deal. Let's look at number 1. Is this in polar form? It certainly is. It may be in the shorthand form of writing polar form, but this is certainly polar form. And if you're like, I don't like that, well then expand it, rewrite it. This will be 2, and in parentheses, what's the C stand for? Cosine. Cosine of what? Good, 45 degrees. Plus, you're like, how do you know it's plus? It's always plus. That's the definition. It's always plus. I, what's the S? Sine of 45 degrees. Okay, so I need to get rid of r and theta and get back to x's and y's. So help me out. What's the first thing that we can quickly get rid of? Or replace. Maybe that's a better way of saying it. Replace. Yeah, you can replace the cosine of 45 degrees, can't you? Because if I replace that, I not only get rid of the theta, but I get rid of the trig function also. So what is the cosine of 45 degrees? Excellent. Square root of 2 over 2. And the sine of 45 degrees? There it is. Square root of 2 over 2. Right? And if you distribute this r through, I'll get rid of the r, won't I? Because technically this 2 on the outside is the r. And when you do that, you end up with square root of 2 plus I square root of 2. Isn't that the rectangular form? Isn't that x plus I times y? Lovely. With me? It's almost quicker to go backwards, isn't it? Okay, let's look at the second one. Again, if you don't like the shorthand, then rewrite it. This would be square root of 2 times, good, cosine of 180 degrees plus I sine of 180 degrees. Got an idea what you need to know? That's right, you need to know the cosine and the sine of a 180 degree angle. So I'm hoping you remember what that is. Good, this one's -1 plus I times 0, which this will just be 0 back here, won't it? So wouldn't this just be negative square root of 2? Awesome! Getting the hang of it? Good. I've got one more example. 4 times the cosine of 240 degrees plus I sine of 240 degrees. Remember, these always match up. And if for some reason these don't match up, then something is terribly wrong. So, know what you got to do? Good. Now, 240 degrees. Which quadrant is that in? Good. That's a third quadrant angle, isn't it? So this is 240 degrees. Remember, this is 180 degrees at the negative side of the x-axis. So this has a reference angle of how much? Yep, this is a 60-degree reference angle. So this is a 60-degree angle. This is going to be 30 degrees right here. Time to label, isn't it? Across from the 30 is the -1. Across from the 60 is a negative square root of 3. And the radius is a 2. Remember, you're in third quadrant, which means x and y are both negative. So a reminder of how to draw the triangle. Okay, so 4 times. So what will be the cosine of our 60 degrees? Yeah, -1/2 plus I times negative square root of 3 over 2. Distributing that 4, what do we get? Yeah, this will be -2 plus, and, oh, this won't be plus, will it? No, it won't be plus. And you know what, let me back up a step because this inside this parenthesis isn't looking so nice. If I write it this way, some of you can see it a little bit better. Is that better for some of you? Good. Now let me distribute the 4, which means we'll get negative 2 minus 2i square root of 3. Excellent. Cool? Okay, so hang in there. I've got some theorems to go along with these polar forms of complex numbers. Okay, so here's a couple of theorems for us. One is a product theorem, one is a quotient theorem. So we're multiplying two polar form complex numbers. Now there's a whole derivation that goes with this, and if you actually have my notes, I show you in the notes, I believe. But here's the deal. This has to do with us actually working with the sum and the difference formulas, identities. That's how we get from the multiplication of these polar form complex numbers into this actual formula for multiplying polar form complex numbers. And the same thing over here. This is the quotient theorem, and we're still using the sum and difference formulas. So when I literally do this division, this is what I get right here. Okay? So pause the video, write these down, and I'll be back with some examples. Okay, so let's look at the directions. They want us to simplify this. Okay? And they're telling us that theta's got to be between 0 degrees and 360 degrees, but not including 360 degrees. We already spoke about that earlier. So I have this polar form of a complex number, and it's being multiplied by this polar form of a complex number. So according to the theorem, what do we do first? Yes, we multiply the two radii. So first thing you're going to do is 3 times 2, right? And then we are going to take the cosine of 60 degrees plus the 90 degrees, because that's what the theorem says to do. Add the two angle measurements. And then plus I sine of 60 degrees plus 90 degrees. Same thing. Are you with me? Okay, not so bad, right? Keep it simple. Truly, these theorems are very simple. So this will be 6, and it's going to be the cosine of 150 degrees, right? Plus I sine of 150 degrees. Do you agree? Now, here's the deal. The directions told me to simplify, but they really didn't tell me if they wanted my answer in polar form or rectangular form. So, the directions will tell you that, by the way. I just didn't write them. Why? Because I wanted you to see what would happen. If they asked me to leave this in polar form, is this okay? Yes, it is. This is okay, and my angle is between 0 degrees and 360 degrees. So if they want the answer in polar form, this is just fine. Okay? This is my polar form answer. So this would be just fine. But if they wanted the answer in rectangular form, we've got work to do, don't we? Yeah, we do. We need to find the cosine of 150 degrees and the sine of 150 degrees, don't we? Okay, so which quadrant is 150 degrees in? Good. It's in second quadrant, isn't it? This is 150 degrees, which means this reference angle here is... Excellent. This is a 30-degree reference angle, isn't it? 60 degrees up here. Across will be a 1. The radius is a 2. And this is a negative square root of 3, isn't it? Because I'm in quadrant 2, so the x needs to be negative, correct? And the y is positive, right? Okay, yeah, all this stuff that we learned how to do in whichever lecture it was is back. It never goes away, so please make certain you still know how to do this. Okay, so if they want the answer in rectangular form, then here's my 6. And now the cosine of 150 degrees, which is the same as 30 degrees, that's what? Negative square root of 3 over 2, isn't it? And if they want the sine of that 150 degrees, which is basically the 30-degree reference angle, that's times a half, isn't it? Okay, so let me just rewrite this and make it a little cleaner looking in the parentheses for some of you. There we go. And now, last but not least, distribute the 6. So what do we got? Negative 3 square root of 3 plus 3i. So if they want the answer in rectangular form, there it is. But if they say leave it in polar form, there it is. Cool? Okay, hang in there. I'll be back with another example. Okay, so let's take a look at this second example. What operation are they asking us to do? Yeah, they're asking us to divide. Now, if you can wrap your brain around the shorthand, this problem is very simple to work with, okay? This is cosine, I sine, right? Okay, so what this is telling me is to divide the 12 and the 6, and then what do I do between the angles? Yes, I subtract, and it's always the numerator minus the denominator, which means I would get 2 CIS of 270 degrees. With me? Now, if they want the answer in polar form, am I done? I certainly am, because this is a polar form answer, so that's no problem. But what happens if they want the answer in rectangular form? Am I done? You're right, I'm not. So, if they want the rectangular form, then we should write it out longhand, because it's easier for us visual people to see what we've got to do. So, to take this polar form to rectangular form, yeah, I need the cosine and the sine of 270 degrees, don't I? Okay, let's see if you remember it. So, the cosine of 270 degrees is, good, 0 plus I times, what's the sine of 270 degrees? Excellent, negative 1, which means we have 2 times 0 minus I, which just gives you a negative 2i, doesn't it? Lovely. Good? Okay, let's look at another example. And that would be 8 over square root of 3 plus I. Now, they want me to do this division. This doesn't seem so obvious to do, does it? Because these are in rectangular form. And in order for us to figure them out correctly, we need to get them out of rectangular form and we need to put them in polar form. Are you guys with me? Okay, so here's the thing. First things first, polar form. Okay, so we need to change to polar form. Because once they're in polar form, they're very easy to divide, aren't they? So, let's look at the 8. I want to change that in polar form. So, technically, this is 8 plus 0i. Do you agree? Okay, that means x equals 8, y equals 0. We've got to find r. So, 8 squared plus 0 squared equals r squared. Good. Some of you are like, well, r would just equal 8. You're right, r would just equal 8. I agree with that. Which means, now I can find theta. Excellent. So, find theta. Like I said, I always take the cosine. So the cosine of theta would be 8 over 8, which is 1, isn't it? Okay. Well, where's my cosine 1? Aha! 0 degrees. That's 0 degrees. Wow. Okay, that's cool. Which tells me this. Instead of 8, I can write r CIS of 0 degrees. Cool? Okay. Let's look at the square root of 3 plus I. We want to change it to polar form. So, x is the square root of 3 Y is 1, isn't it? Because that's the coefficient of the I. So to find R, we got square root of 3 squared plus the 1 squared equals R squared. Yeah, what's this squared? 3 plus the 1. So 4 is R squared. And R equals, excellent, 2. Now what? Good. Find theta. This is a really good problem because it makes you first and foremost remember how to convert rectangular rectangular complex numbers into polar form complex numbers. So this problem is really good. And some of you are like, uh-oh. Anyway, so cosine of theta is x, which is the square root of 3, over r, which is 2. What is that? Draw your triangle. You're like, I don't know. Draw your triangle. So, 30 degrees, 60 degrees. I'm going to label everything accordingly. Which one? Looks like it's a 30-degree angle, right? Because if I take the cosine of 30 degrees, I get square root of 3 over 2. And this is quadrant 1 because x and y are both positive. So theta is actually 30 degrees. So 2 CIS of 30 degrees. With me? And some of you are like, are we done? Well, wait. What was the original problem? Yeah, the original problem asked me to divide, but I don't know how to divide complex numbers in rectangular form. I do know how to divide them in polar form, so we changed them to polar form, didn't we? Okay, so now that they're in polar form, can I do the division? Yes, I can. So clearly I'm just getting myself some board space here, aren't I? Okay, so to do the division, it's easy to divide the radii, because you're just doing 8 divided by 2, aren't you? Well, what is 8 divided by 2? Yeah, this is 4. And to do the angles, you subtract. So 0 degrees minus 30 degrees. This is going to give me a negative 30 degrees, isn't it? Well, you know, that's not so good. Because if you remember the directions said that they wanted the angle between 0 and 360 degrees, which means they wanted a positive angle measurement that was between 0 and 360 degrees. We have a negative angle measurement. So if they want the answer in polar form, can I leave it with the negative angle considering the directions? Nope, I cannot. Not allowed. So, negative 30 degrees is in which quadrant? Excellent. Quadrant 4. Good job. So, and some of you are needing to draw it. So, which is why I was getting more board space. This is a negative 30 degrees, right? From 360 degrees, which means, yep, 330 degree angle. So this can be rewritten as 4 CIS 330 degrees. And if they want it in rectangular form, you guys can put it into rectangular form. But for now, that's where we're going to leave it. Cool? Again, this was a really good problem. This really put all your knowledge together, especially if they ask you to put the answer in rectangular form, because now you got to work that out too. So hang in there. There's 2 more theorems